And we're live. Welcome, everybody, to this presentation with Garima Gujral. She is an ontologist at Amazon, and yeah, her skill sets extend into taxonomy and ontology development. She has authored over 50 publications across a number of domains. Without further ado, I think we all want to just jump right into the learnings that Garima has derived from her experiments. So,
Great. Yeah. Thanks a lot for the warm welcome, and thank you everyone for taking out time and joining this session. Today, I'll be sharing some of my learnings and experiments that I did with LLMs to generate ontologies. And yeah, I can jump right into it. So, this would be the contents of my presentation, where I'll begin with a brief background of ontologies and the challenges that we face on the day to day basis when we do it manually, uh, introducing the role of LLMs and our initial conception of idea to the experimenting stage and the lessons that we learned throughout. Okay, so before I begin, I usually like to begin with this slide. If here we have these five pictures, and as we see the first picture, which is a random set of blocks or disparate pieces of data, if we say, which make no sense. But as we move ahead and prepare it, sort it, make it visually understandable, and finally, in the fourth and fifth picture, when we start linkaging and create these meaningful relationship or linkages, it tells a story, it gives it meanings. And that's what ontologists do on a day-to-day basis. We try to build relationships between different data entities, separate spaces to give it more meaning and understanding. Now comes the part, this is something which a machine can do. It's why do we need ontologists or this domain expertise to come into place? To which this is a tweet that I came across a few years ago, and it grabs my attention, which says anybody who thinks taxonomies, or I would also say interchangeably, ontologist can be universal and perfect, is invited to put away a load of dishes in somebody else's kitchen. I really relate to this because every day, every project, every aspect that we try to build ontology requires an in-depth research or expertise into that particular field, and there's no short formula that we can go by. And yeah, coming back to ontologies, in the first picture, when we saw the blocks and the interlinkages between them, so what are our ontologies? Ontologies basically exists within our language, and it's basically our primary information about an item or the language describing the item. And I would say from my experience of dealing with e-commerce ontologies for Amazon, for a cell phone, the language that describes it's the color, the memory, the camera, the screen size. These are all the different metadata facets, which are also our language. So this whole core is built upon language, and our experiment focused on utilizing large language models to see if we're able to get the same expertise or results as a human designing those ontologies. If we try to understand ontologies, there's a very basic ontology that I have it here, where we do using different language aspects to define the relationships between Mona Lisa, painted by where is it right now, where is it located, who likes it. So this whole graph like visual is a simple ontology for our entity Mona Lisa. This is how we can just have a broader understanding of what an ontology is. And here's like a more formal definition of an ontology and the crucial role that they play in AI, data integration, knowledge management, and understanding and transferring complex pieces of information. Coming to the importance of ontology generation in our modern digital landscape, ontologies act as the backbone of knowledge organization, and This is a screenshot of a Google search. This is something which we interact with daily and come across it on a day-to-day basis. It's the Google knowledge graph, if we look at the right, where when I shot a small search with 3 keywords, Albert Einstein education, it gave me all these disparate pieces of linkages with respect to the awards, his family life, and so on. And there's a growing demand for accurate and adaptable ontologies in various domains lately. Moving on, here I've listed some of the key characteristics of ontology. Sometimes we confuse it with just a visual representation, but it's way more than that. It gives us the semantic context of interconnected data. It's scalable and flexible. It defines various entities and relationships and facilitates advanced analytics. And one of the comparisons that I always make between taxonomies and ontologies that we work on a day to day basis is like a taxonomy would be something that I can relate to as a menu for a restaurant where we have one title like starters, dessert, main course. And ontologies is something that you can relate to as a recipe where we are talking about all the elements, the different ingredients, the different dishes you require, the origin of that recipe, and so on. So as you see, it gives us a more three-dimensional layer. And that's what we wanted. If LLM is able to understand and process this three-dimensional layer, and we face several challenges in our ontology development, such as it is a tedious task, and especially with the dynamic changes going around, it can be very resource intensive to keep up the ontologies up to date. One of the examples that I come across from the e-commerce side again is often when we create ontologies for electronics or phone models, in like less than 6 months or a year, we have a new model that's out in the market. So it's very difficult for somebody to manually keep up to it and keep adding those entities. How do we automate that process and so on? So when we came across these challenges, we thought of leveraging LLMs to see if it can help us reduce our task. And there comes the role of large language models. As I discussed initially, ontologies are language, our metadata is language, and LLMs, a powerful AI tool, often have a potential to significantly aid in ontology generation by automating parts in the process, reducing manual efforts required. Okay, moving on. So we often confuse LLMs as something, is it a chatbot? Is it just retrieving knowledge, or does it have a knowledge base of its own? So this is a sequence diagram that I tried putting together where we see LLM as a knowledge base as well as a knowledge retrieval system. Now, coming back to our initial conception of ideas of how we leverage that. So, what we imagined was to streamline some of the tedious and manual processes. And our early brainstorming sessions focused on identifying specific areas. For example, one of the areas that I started with was to identify semantic duplicates within our ontology. And talking in terms of retail again, if we have screen size or phone screen kinds, which we say it's like linguistically it's different, but semantically it's repeating to the same. Or camera resolution, cell phone camera video resolution. So one of the initial experiments that I ran with LLM was to detect these semantic duplicates. Another areas that I ran the experiment was around catching misspelling, something as Jessica at that, where we gave certain guidelines in our prompt to the LLM to identify misspellings. Then there was one experiment where we had very long or verbose labels for filters, and we tried using LLMs to suggest improved labels, which would lead on to better customer interaction and usage. So this is where our initial conception began. and we tried to come across areas to use. Now came our experimentation and the early adoption stage. The early adoption stage required a lot of hits and trials and working like multiple prompts towards getting a good precision and accuracy. And when we started beginning with our prompt engineering, these were the 5 levels that we started was where we gave it a directive and a data point. The level 1 included of a very simple sentence directive expressing the high level goal. For example, define a pillow. Then we came across the multi-sentence directive where we started giving it subtasks like define a pillow, give us the multiple brands of pillows in the market, what is the thickness that are popular, what are the dimensions that are there. And here we were still dealing with a low level of detail, then followed by level 3 and 4, where we dived deep into a moderate level of detail. We had very complex directives that included a high level goal, list of subtasks, and also asking LM to explain its own input, to provide us a justification. Why do you think if something is true or false? Explain it. And I tried this particular experiment by giving the LLM certain brand names, asking, is this a misspelling according to you? If not, why? And we were able to get results like, oh no, this is a proper noun, even as per the guidelines we gave and so on. And our level 5, which was around complex directives, including high level details, list of subtasks, statement asking LLM to explain its own output, also some of the statements of exclusion that we gave, and example guidelines with where we supported the prompt with existing examples. And when we dived into this stage, there was one aspect where we felt the LLM system started hallucinating because when we started giving it a prompt multiple times, it felt like it needs to answer in a better way, and we could observe some hallucinations. At this point, what we observed was including an exclusion statement was really helpful, where we said, if something is unclear or not understandable, respond by saying you cannot provide an answer for that. So, looking at the various techniques we used for building the prompts were simple question and answer pairs through a chain of thought where we provided an idea, asked it to build upon that, and gave some details, subtask, and tried building a series of prompts instead of a single short prompt. Next technique that we used was reasoning and acting, where first we asked it to review, and for example, where we felt, oh, these labels or names are very lengthy for an e-commerce website. Justify your answer, and if you feel they're lengthy, suggest a new name. And the next aspect came was narrative braiding. Here we tried intertwining various narratives. For example, we talk about, say, build a taxonomy or ontology for men's clothing, keeping in the aspect of sustainability. So we tried intertwining two narratives and see if it was able to perform or not. And yeah, again, these were also some of the techniques that I used was by providing it a real world or a proxy context. For example, beginning my prompt by saying, consider yourself as an ontologist. Consider yourself as an catalog specialist for an e-commerce website. Consider yourself as an auditor auditing misspellings. Then another two areas was leaving a way out as well as leaving room to think for the LLM, where we didn't provide all the instructions, but also left some room for it to think and respond. Another technique which I felt was really helpful for me was using XML tags for step enforcement or writing examples, and Last one was breadcrumbing. That was through our series of prompt where in the first prompt when we found certain findings, we utilized that to build on the second and took out like sample sizes out of it, because there was one observation that we found was when we tried giving too many instructions in one prompt, the LLM tend to hallucinate. So breadcrumbing was another technique that we utilized. Here's a very simple example that I tried putting here, which is an ontology creation prompt for cell phones. So I tried giving certain subtasks in it where I specified that, the fundamental attributes should be around brand, model, release year, and specify the main components. And I need a detailed battery related concepts. Or here I tried braiding another narrative around relationships between price ranges and so on, and security features. So this is the prompt that I tried on ChatGPT 4, and here's the structured ontology that I got in return, which was given to me in the form of flat list, but it listed all the fundamental attributes as requested, the components, and if we look at where we gave a second instruction specific subtask for battery related concept, we had a separate subsection where it gave battery related aspects such as the charging methods and so on, the market data with respect to the pricing and trends with sales figures, and the price range and model related information ranging from low range, mid range, and so on. Now, yeah, here are more relationships with respect to brand models, and it tried giving us a brief summary of all the relationships that it tried building through this ontology. Another prompt example that I've put together here is where I asked it to give me a visual aid as well, and I got this response. I tried developing an ontology that classifies books based on age ranges, including categories for young adults, preschool, early readers. And as you can see, it tried giving us separate sections for book categories, the aspects that we'll require are the metadata elements for a book, and the various entities and attributes. If we look at, we have the different categories and the metadata elements. But as we can see, this was a more intertwined concept. It wasn't giving us an explicit relationship where it had age ranges. Whereas if a human ontologist would have tried building this, we would have tried to classify it on the basis of the level of complexity, the material, if it's a children's book, is it like a hard card bound book or so on, which is something where we felt that it wasn't that clear. So I tried putting two examples, both of the cases where we were very satisfied with the result versus where we felt that we need to work more on the prompt and refine it and iterate it further to get the exact results. And moving on, yeah, I'd like to summarize the lessons learned through this exercise. One was submitting requests multiple times with a slight variation did yield multiple results, and the prompts greatly influence the task. And crafting the prompt with the right amount of detail is very important. And by this, I don't mean that we need all the details as possible. Sometimes less is more, and I could feel that when I tried giving too many details, the results were not satisfactory, the precision was low, and very specific crisp details helped more. And last but not the least, there's no rule book to prompt engineering. It's still an iterative process, and yeah, we can experiment with it, play around with it, and get to learn on the way. And if we look at the significant breakthroughs through this exercise, One was successful automation of ontology generation tasks for the problems that initially we picked up, high accuracy and precision ratios that we came across, and reduced time and effort at the end once the tasks were automated. Of course, we came across several challenges on the way, especially when we deal on a very large scale, which was with respect to ensuring our data quality and consistency. Our initial set of results required a manual review. The design and maintenance, because it's not a job that we can start once and end it. Entity disambiguation, privacy and security concerns once we are dealing with confidential data, user adoption and training amongst the team, and performance optimization of querying with the tool. Moving on, these are some of the best practices that I could summarize was to start small and scale gradually. Smaller experiments leading to builder adopting an agile approach instead of expecting great results in the first go, prioritizing our use cases, creation of custom ontologies instead of us giving it multiple domains together, like, say, for electronics with consumables and confuse the system. Understanding our data first, trying to synchronize it universally and ensure it's scalable, leveraging our existing taxonomies and ontologies to get the best possible result, using that as a training data for the model. And if we look at the future outlook and research directions, I would say LLMs do hold a great potential for transfer learning and cross domain ontology. And I could vision integrating images or other modalities that will lead to more comprehensive ontologies. And yeah, I'd like to conclude by saying that looking ahead, future research for us will focus on enhancing the scalability and adaptability and envision a future where LLM plays a role in automated knowledge engineering and beyond. These were our references, and thanks again for this opportunity. Hope it was.
Garima, that was wonderful. Based on these experiments, based on these findings, do you see yourself with your team creating guidelines or instructions as to how to employ this in other environments, sort of to build on your work?
Yeah, so as we built on these experiments and played around, we also worked in developing like a playbook for the team to follow, where we tried mentioning our best practices as well as things that do not work so that we do not reinvent the wheel. So, of course, a guideline would really be helpful as this is in its nascent stages and we're all in a hit and trial phase. Yeah.
Do you see yourself in the future using more specialized LLMs that may be trained with the domain that you're developing a ontology for?
Yeah, certainly. Yeah, I do see. Especially, I feel domain knowledge will be something that will be very conducive because at this point, we are the ones who are first providing it the knowledge and then asking it to work on it. But if we have specialized LLMs with domain knowledge, that can be great. Yeah.
We're open to questions, but yeah, what do you see? What do you see with small language models? Do you see any opportunity there?
Small language models, could you share some examples in terms?
Yeah, like taking an open source large language or model based on a data set that is very smallly defined and maybe fine tuning it.
Yes, like one opportunity that I see there is around more of knowledge retrieval, if not as a knowledge base. That is something that can help our users work efficiently. Yeah.
Great. Um, yeah. Any other further experiments that you're going to run after this one?
Yeah, we have certain experiments lined up, both on the schema generation side as well as maintenance side. Generation side is something where we'll try to generate newer attributes of facets, and maintenance side is the areas where we already know are problematic areas and we're trying to look out for a fix. So these are the two directions that I have on my mind as of now. We want to work on it parallelly.
There are other people that are looking for ways to integrate LLMs and knowledge graphs to enrich the retrieval of more relevant information based on existing structures. Is that something also you'd like to experiment in the future with? Building like a graph rag to support further ontology refinement?
Yes, certainly, because I feel once we have the graph rag in place, that's where we can get more knowledge about our accuracy and precision in a more automated and refined manner, but rather than a manual review to confirm. The graph rag can help a lot in providing us with the accuracy and precision values and calculating that to make it more better. Yeah.
Well, thank you very much, Garima, and I look forward to learning what comes next out of your experimentation, and if you find any reliable methods for scaffolding ontology development.
Sure. Yeah.
And
Good.
yeah, we're gonna take a short break, and then we're gonna get on with the next presentation on developing explainable AI powered by ontologies. So stick around, and we'll see you in about 13 minutes.
Great. Yeah. And thanks again for this opportunity. And I'd like to thank all the audience as well. Have a good day.